What's up, folks? Today, we will make America great again through education. When two asymptotes are perpendicular to each other, we get a square hyperbola. We have this asymptote y equals b divided by a, and this one with an opposite slope. For two lots to be perpendicular, their slopes must be opposite reciprocals. That means a equal b. We have a regular hyperbola equation. Replace b with a. We get the formula for the asymptotes. Replace b with a, and we get the equation. We have the general focus of hyperbola formula. Replace b with a, and we get the formula. We have the eccentricity equation. Replace c with a, and we get the equation. We have the directrix equation. Replace e with the square root of 2, and that's where the equation came from. We have a normal square hyperbola. Now what happens if we rotate 45 degrees? The equation of 45-degree square hyperbola will be xy equal a squared divided by 2. The asymptotes will align with the coordinate axis. We have a. Rotate 45 degree. Using Pythagoras theorem to get the coordinate. We have c equals square root of 2a. Rotate 45 degree. Using Pythagoras theorem to get the coordinate. We have the regular rectangular hyperbola directrix. Rotate 45 degree. And we have a line with -1 slope. Using Pythagoras theorem to get the coordinate. And the directrix equation is y equal -x plus a. The locus of a hyperbola is the difference between the distances to two focuses is constant, equal to a. Using the distance formula, and we get this. Rearrange, square both sides, expands, simplify. Simplify again, rearrange, square both sides, expands, again. Simplify, rearrange, and we get the equation. Make sure you like, share, and subscribe, or else
You are fake news.